Hey guys, today I got some rings in the mail, the asymmetric chin rings. They're not round, and I want to see how a crank-based power meter reads um, differently if it does from round rings to oddly shaped rings. Um, so I couldn't find the answer online. I looked on some forums. One person said it reads a little higher, 3% higher. I called Quark this morning and they said it may or may not read higher or lower. The omnical feature in the Quark Riken will take care of the difference in slope. They were saying that there's no difference in slope. Um, so what's going to happen with um, a different shape, a non-round ring, is that you have a power phase and you're going slower, but you have lots of power, and then your weak spot, you go fast. So does it compensate? I don't know. So the way I'm gonna find out is I have my bike on a Wahoo kicker. I made a program from Trainer Road that I uploaded on the iPad. That's gonna be the remote for the Wahoo kicker, and I'm gonna sample from the power meter with the Garmin for a minute at different powers. I'm gonna sample at 150, 200, 250, 280, 310, and 370 watt for a minute. So I'm gonna do this with the round rings and then with the new rings and see if they're different because the trainer is gonna stay the same. So I did the warm up on the trainer. I performed a spin down to calibrate the Wahoo kicker. I set the zero on the Quark Riken and I did the program. I took my intervals, my samples on the round rings. Taking these off, I'm careful not to set any different. I'm careful not to calibrate the power meter because I want it to stay the same way it was for these guys. I want it to be for the new rings. So I'm gonna put the new rings on and do it again, and we'll see how different they are. This is not a review. I'll review these rings later once I know, but right now I just wanted to see how they might be different.
So here are the results on a spreadsheet. So follow the cursor, it's a little messy. So here I have what the program told the kicker to do, what the kicker actually did, what the power meter with the factory round rings read, and that's going to be my baseline. Here we have the difference in watts and the difference in percentage. So that's my baseline. I want the Quark to read with aftermarket rings the same way as it did with factory rings. This is the power meter. The kicker is not a power meter. It's a smart trainer. So I'm going to trust the power meter over the little difference from the kicker. So same thing here. Now we have the power meter with the asymmetric rings. And we have a new line of numbers. So to make this easy for you guys, I have SRAM factory rings, aftermarket asymmetric rings, and you see the difference in the numbers, and we could look at it and we see that it's always reading high. Putting non-round rings on a power meter will make the power meter read high. End of discussion. Like on a crank-based power meter, on a spider-based power meter, it will read high. And it could read quite a bit higher. So here we have the absolute difference and the relative difference. So yeah, it could read up to 28 watt higher, maybe more if I went harder. So yeah, so now I'm gonna scroll down just to not show the calculations. So now I have the numbers here, and I want since I have a Quark, there's a mobile app, Calvin, which allows me to talk to the Quark unit and I could change the slope. That's one of the features. So you could do this if you have an Android phone or if you have an iOS device with an ANT Plus dongle. So it's reading too high. That's my issue. So if I reduce the slope by 7%, those are the kind of numbers I would be seeing. 6%, here we go, 5 and 4. So in each column, I put in bold the number that matches the factory SRAM rings on the Quark. So if I went down 5%, it would read 284 when it's actually 284. But before that, I would be lowballed a little bit. and then above it would start reading high. Same thing for 6%, just the number that matches is different every time. And I chose to go with a 6% one because I care about numbers in the early 300s. That's where my FDP is, and that's what matters to me. If I took 5%, it would start reading high too soon, and then here it would lowball me on numbers that matter for me. So I chose that a reduction of 6% would be best suited for my application. I'll lose 3 watt. I'll read 3 watt lower at 140, but that's not I don't care about that. And then it reads 3 watt higher at 388 instead of 385. Not a big deal. And then the way it works with Quark is like you have numbers, and then that's what it came with. So it came at 458, and I changed it to 434. And yeah, so that's what it is. So it will read high. Those are not gains. That's the power meter not reading correctly. Yeah, so you would have to either recalibrate, real calibration, not setting the zero. A lot of people get that mixed up. Or you have to change the slope or something to get numbers to match. Thank you.